8.2 notes, graphs of the other trigonometric functions. This is page 6. So we've graphed tangent, and so now we're going to look at some of our reciprocal functions. We are going to start with cosecant because we started with sine when we graphed first. Okay. And we're going to take a look at this the way we looked at some of the other ones. We are going to start by creating a table. And so I want to start by graphing sine. Cosecant is 1 over sine, so it's going to help to have the sine in there as a reference. So the sine of negative 2 pi is 0. The sine of negative 3 pi over 2 is 1. At negative pi, we're back at 0. At negative pi over 2, we're at negative 1. At 0, we're back at 0. Pi over 2, we've got 1. And then at pi, we're at 0. 3 pi over 2, our sine is negative 1. And at 2 pi, our sine is 0. And so what I'm going to do is go ahead and graph that first. So we can kind of separate out the graph of that from the graph of cosecant. Negative 3 pi over 2, negative 2 pi. I'm going to count up and down by ones. And our sine was 0 at negative 2 pi, 1 at negative 3 pi over 2, 0, negative 1 at negative pi over 2, 0 at 0, 1 at positive pi over 2, 0 at pi, negative 1 at 3 pi over 2, and back up here to 0 at 2 pi. And then we're just going to sketch in our sine curve. 2 periods, right, from negative 2 pi to 0, and then from 0 to 2 pi. Okay. Now that we've done that, we're going to go ahead and crank out our values for cosecant. Quick reminder, cosecant is 1 over sine. So at negative 2 pi, 1 over 0 is undefined. At negative 3 pi over 2, 1 over 1 is 1. Back to undefined. Negative pi over 2, 1 over negative 1 is negative 1. I've got an undefined, 1, undefined, negative 1, and undefined, and that doesn't feel like it helps me a whole lot. Let's see what we can start with. I'm going to go ahead and start with the undefines. Anywhere that sign is 0 and it ends up in the denominator, I'm going to get a value that I cannot use. So I know that for my cosecant, anywhere the sign is 0, I'm going to have an asymptote. So multiple asymptotes here at the end of each period and right in the middle. I also notice that sine and cosecant, share these points right here. The maximum for sine and the minimum for sine. Cosecant hits at those values. Okay, and now I'm at a little bit of a loss because I don't want to think super hard about what's going on here. So I'm going to pick another value. I'm going to take pi over 6 because it lies between 0 and pi over 2. I know that the sine at pi over 6 is 1/2, which means the reciprocal of that is 2. So on my graph, I roughly place in pi over 6 here. I'm at 2. And I know my graph has to go through both of these points. Approach the asymptote but not cross. Keep in mind it couldn't double back down and cross over the x-axis because we don't have any zeros other than where our asymptotes are. And so from every maximum in the sine graph, our cosecant is kind of parabolic looking going up, and from every minimum, our cosecant's going to approach those asymptotes heading towards negative infinity. Now, this dark purple curve in the middle, you guys, that's the sine. That is not part of our cosecant graph. it is not going to bother me if you have that in there when you graph cosecant, or if you have the cosine function in there when you graph secant. It's going to be helpful because you've had more experience graphing sine and cosine. Use those as a reference for your cosecant and secant. Okay, so for our cosecant function, our domain is all real numbers, except for where x is some multiple of pi, right? Anywhere sine is 0 or cosecant is undefined. So n pi, k is an integer. Our range, excuse me, notice that in here in the middle, we have no values of cosecant. Okay, other than 1 and -1, anything we can use for sine, we're not going to see as part of that cosecant function. So our range goes from -infinity to -1. Remember, it's always a parenthesis at -infinity. We're not including that. It's not a number. There's a square bracket at -1 because we do hit -1 in our cosecant function. And then we need the top half. +1 to infinity, 1 is included. The period, it's got to be a full repeat, right? So same as pi, our period, or sorry, same as sine, our period is 2 pi. Amplitude, how far it goes up and down, how far between the maximum and the minimum. So our cosecant does not have an amplitude. Okay, it shoots up towards infinity, down towards -infinity. So when we looked at asymptotes for the tangent function, we noticed those asymptotes occurred where we had holes in our domain. Same thing happens here. The equation of the asymptotes, and you'll see that it's written in case we have something that's shifted, x over the absolute value of b times k. Here our b is 1, it's just cosecant 1x. So our asymptotes are at x equals pi times k, where k is an integer. Okay. All of those features are recorded for you down in this box. Please change my typo. I believe your version says a secant bx. It should be a cosecant bx because we have been graphing the cosecant.